Hello everyone. Last time we were talking about central limit theorem for sample means, and in this video session we are going to do a lot of examples on it. So let's once again see what is the central limit theorem for sample means. It simply says as n increases, that is the sample size, the random sample mean, which is denoted by x bar, behaves more and more like a normal random sample variable with mean mu and standard deviation sigma over square root of n. Keep in mind, guys, that the mu here is the same as the population mean, and sigma is the population standard deviation. So in order to find the the sample mean and standard deviation, we need to know the population mean and the population standard deviation to find our answers. So the central limit theorem is a very, very important. What it simply says is as we increase the sample size for our sample data sets, the sample mean, which is a random variable, behaves more like a normal random variable. And we all know that a normal random variable is reported in terms of its mean and standard deviation. So thus we need to know the mean and standard deviation of a random sample mean. And here it says that the mean of a random sample mean x bar is mu. That is the same as the population mean, and the standard deviation of the random sample mean is given by sigma over square root n. Okay, now we are going to look at examples. So our first example is for the population of farm workers in New Zealand. The weekly income has a right-skewed distribution with the mean of 500 and a standard deviation of 160. A researcher randomly picks 100 farm workers and uses the sample mean annual income, denoted by x bar, to estimate the population mean, denoted by mu. So remember, the central limit theorem says that no matter what the distribution is, if you have a large sample size, then sample mean behaves more and more like a normal random variable. So if our farm workers in New Zealand population, even if it is right skewed, but because we have a larger number of sample size, remember if we talk about the 25 and above, if you remember from our previous videos and classes, that if you have a sample size greater than 25 or 30, then any kind of distribution is represented as a normal distribution. Okay, so for the population of farm workers, the weekly income has a mean of 500 and a standard deviation of 160, even though it is right skewed, because we are having a size greater than 25, that means 100, then this sample mean annual income is going to be behaving more like a normal random variable, and by central limit theorem, the mean and the standard deviation would be basically the mean of the population mean, and the standard deviation would be sigma over square root n. So let's look at the first question again. What is the mean of the sample mean? The mean of the sample mean, guys, is given by mu subscript x bar, and it is the same as the population mean. So the population mean is what? 500, and that's what goes here. Now what is the standard deviation of the sample mean? The standard deviation of the sample mean, the other terminology standard error, is given by sigma x bar, which is equal to sigma over square root n, which is 160 divided by 100. 100 is the sample size, guys, which is equal to 160 divided by 10, which is 16. Okay. So remember, as our sample size is 100, thus the sample mean has a normal distribution with mean, mu, and standard deviation, sigma over square root n. Just keep that in mind. Very, very important, guys. That if you have a sample size greater than 25, no matter what your distribution is, this distribution will behave like a normal random variable. So our sample mean, because the sample size is 100, is now going to behave like a normal random variable with mean, mu, which is the same as mu of sigma x bar. This is the mean mu I'm guys talking about. This mean mu. So in other words, let me write this one, n of mu of x bar and sigma x bar. So mean of mu of x bar is mu and sigma of x bar is sigma over square root n. Okay. So now, because we can apply all the things we learned in the normal distribution, so our sample mean, the sample mean, guys, is a normal random variable. Remember that. Okay. Continuing further on the same problem. So here we would like to sketch the sampling distribution of the sample mean. Now remember, the sampling distribution, that is this, of the sample mean is a normal random variable with mean given by mu x bar and the standard deviation given by this, which we just have proved to be mu and sigma over square root n, which is the same as n. Mean is what? 500. And we found sigma over square root n to be 16. Now if you want to sketch the sampling distribution, guys, do you remember? Make the number line and draw this nice little bell-shaped curve. Doesn't look like, but the mount is where it is going to be 500. Now we go, one standard deviation would be what? 660, right? And then you add 660, adding 160, what are you going to get? 820. And then you add another 160, what do you get? 980. So that's basically filling up the right hand side. Now let's go to the left hand side. So 500 minus 160 is going to be 340. Subtract another 160, you get 180, and subtract another 160, you get 20. Okay, remember the mean is 500 and that's where your mound is. The bell-shaped curve, the mound of the bell-shaped curve is right over the 500, the mean of the sample mean. Okay, so this is the sampling distribution of the sample mean. Remember, it has a normal random variable. So now we will like to find some probabilities here. Okay, let's continue further on the same problem. It says, the same problem, let me repeat it. For the population of farm workers in New Zealand, the weekly income has a right skewed distribution with a mean of 500 and a standard deviation of 160. A researcher randomly picks 100 farm workers, and now it uses the sample mean annual income to estimate the population mean. Okay, the question is, find the probability that the sample mean falls above $540. Okay, so if we quickly make a little, bell-shaped curve, and from the previous one this was 500, and the next standard deviation was 660. Now we need to find what is the population, the probability that the sample mean falls above 540. In other words, this is very close to 500, 540. So we want to find the probability it is above. Okay, so it's a mess here. Let me just write this nicely, 540. Now, you want to find the probability that the sample mean is greater than 540. Now, if you guys remember your formula, the normal CDF, the lower limit is 540, upper limit is 999. Then the mean, this guys is the mean of the sample mean, and this one is the standard deviation of the sample mean. You plug this in, you get 0.0062. Now let's go ahead, take your calculators out. We would like to see it. So let's take your calculators. Click on second and wars. Now you want to go to the number 2. Take your cursor to number 2, press enter. So you will have a lower limit. The lower limit is 540. The upper limit is 999. The mean is 500. And the standard deviation is 16. Take the cursor to paste, enter. So you will see, oops. Where did it go, guys? Oh, here it is. Okay, then press enter and you get the answer to be 0.0062. Okay, and that's what is our answer over here. Now, let's look at the fact okay, so we're looking at now what is the probability that the sample mean falls within $20 of the population mean for all such workers. So what does it basically means is that if we have our little bell-shaped curve, so if 500 is the sample mean here, then we are going to mean of the sample mean, you're looking at 20 to either side. What is the probability that you are looking at the sample mean falls within $20 of this population mean? So in other words, 20 to the left, you go down 20 left and you go 20 up. So what you're looking at is 480 and 520. So the probability 480 strictly less than x bar less than 520 is normal CDF. 480, 520, 516, and when you plug it in you get 0.7887. So let's go ahead and quickly do the math here in our calculators again. So now go to second and wars. Take the cursor to normal CDF. Then the lower is now 480. Upper is 520. The mean and the standard deviation is the same. Take the cursor to paste and then press enter. And you get the answer to be 0.7887. Okay. Now, let's look at another example. This example says, you are on your shared wireless plans with your parents, who are statisticians. A recent personalized information from your wireless carrier claims that the mean duration of your phone calls was 2.8 minutes with a standard deviation of 2.1 minutes. So you would like to sketch the population, so this is your population distribution for the duration of your phone calls. What is its mean and the standard deviation? Now remember, this is the population distribution. In other words, in this problem, you are on a shared wireless plan, and the wireless carrier says that the mean duration of your phone calls was 2.8 minutes and a standard deviation of 2.1 minutes. So for this population distribution, the mean is what? 2.8 and standard deviation 2.1. So if I sketch the distribution, let's see what happens. We say 2.8, remember that's where the amount goes. And if I add 2.1 to it, it's going to be what? 4.9. And then when we add another 2.1 to it, what are we going to see? A 7. And then another 2.1, 9.1. Okay? Now if you go back, so that means this is how my graph looks like. Now 2.8, subtract 2.1 from it. What are you going to get? 0.7. Now clearly you cannot have a standard deviation to be negative. We all know that. Standard deviation can never be negative. It can be 0. 0 means there is no variation. Remember, standard deviation means the variation in the data points. So when it is 0, there is no variation. So what does this tell us when I draw the sketch distribution? Clearly, this population distribution is skewed with the mean of 2.8 minutes and sigma to be, that is the population standard deviation, to be 2.1 minutes. Okay, now let's look at the problem from the sample mean point of view. Now it's the same problem. You are on your shared wireless plan with your parents. They are statisticians, and a recent personalized information from your wireless carrier claims that the mean duration of your phone calls was 2.8 with a standard deviation of 2.1 minutes. So what your parents do is they took a random sample of 45 calls. And they would now like to find this random sample of 45 calls to look at that, the mean and the standard deviation of the sampling distribution of the sample mean. So randomly they're picking 45 calls, and they're going to use this to estimate the population mean here. So what is the mean of the sample mean? So the mean of the sample mean is mu x bar, which is the same as the population mean. But what is the standard deviation of the sample mean, which we call the standard error, which is sigma x bar, which is defined as sigma over square root n, which is 2.1 divided by square root 45, which gives us 0.31. Okay, so this is the sampling distribution of the sample mean of 45 calls. Okay. Now we'd like to look at if the sample mean was 3.4 minutes, then we would like to know, is it really high or not? So that's the next question on the same problem. It says, is the sample mean of 3.4 minutes unusually high? What it basically is saying is find its z-score and comment on it. Now remember the z-score formula. It is x minus mu of x bar over sigma x bar. That's a z-score. So x, guys, over here is 3.4 minutes minus 2.8 divided by 0.31. We get the answer to be 1.94. Remember that when you take a sample size of 45, no matter what kind of distribution, here the distribution was right skewed, the sampling distribution of a sample mean of size 45 is always going to be a normal distribution. And this distribution is bell-shaped. So compared to a bell shape, it is not extreme, as it is within 2 standard deviations of the mean. Okay, now let's look at another example. It says the amount of pudding in a cup is supposed to have mean of 101 grams and a standard deviation of 1 grams. Assume that this distribution is normal. So if I take a sample of 25 cups, then what we have learned in our previous chapters, that if you have a size of 25 or more, but if the distribution is normal, then every sample taken from that distribution is going to be a normal distribution. So clearly, the sample of 25 cups, the sampling distribution of the sample of 25 cups is going to be a normal distribution. Now let's look at the questions. It says, what's the approximate probability the sample mean amount of pudding is less than 100.5 grams? Now before I can actually solve it, I need to know the parameters of the sampling distribution of the sample mean. Now remember that the sampling distribution of the sample mean is a normal distribution with mean given by mu x bar and sigma x bar. The formulas which we have learned, because we are having a normal distribution, so any sample taken from a normal will be a normal distribution. It will be mean, mu, and sigma over 6 square root n, which is n. Mean is 101, and sigma over square root n is 1. Standard deviation is 1 grams, 1 over square root 25, which is n 101 and 0.2. Okay, so we see this is our normal distribution, okay, and the sampling distribution of the sample mean is a normal random variable. So we would like to find or approximate the probability that the sample mean amount of pudding is less than 100.5 grams. So the probability that the sample mean is less than 100.5 is normal CDF, negative 999, 100.5. Now this 101 is the sample mean, and this is the standard deviation of the sample mean, which is 0.2. Okay. This one is this, guys. Okay, now to find this one. The answer is 0.0062, but we are still going to use our calculators. Let's go ahead. Do second and wards. Take the cursor to number 2. Press enter. Now here the lower limit is because you're looking at the amount of pudding less than 101.5 grams. So what does that mean? That this is negative 999. Got to be careful, guys. This is the negative we have to use, not this minus sign, this negative. Right, 999. Then this is 101.5. The mean is 101. The standard deviation is 0.2. Then take it to the cursor, paste, enter, enter. Oops, I have made a mistake, guys. I think what is the value? It's 100.5, not 101.5. Sorry, guys, it's 100.5. So let's go ahead and do it again. This time I just have to make a change in one of the values. This was the mistake I made. It is 100.5, not 101.5, sorry. And it is less than. So paste, enter. It's 0.0062. Okay. So now that's the answer we have. Now what is the approximate probability? It will be between 100.6 and 101.4 grams. Now what I would like to do is, for this problem, I would actually like to show you something, make the novel curve and show it to you, and then we talk from there. Okay, so let's look at the normal curve, guys. So when I make the normal curve, this is 101. Now we're going 0.2. Next one would be what? 101.2. The next one would be 101.4. Okay, this one I'm talking about. Now let's go here. One down is 0.2. This is 100.8. And the next one is 100.6. So we would like to know the probability that this sample mean for the pudding is going to be here. Notice that this is 2 standard deviations to either side of the mean. If you remember your empirical distribution, what does empirical distribution says? That there are 95.44% of the data between 2 standard deviations of the mean. So our answer is, if I simply use my empirical distribution rules, it is 0.9544. I'm using simply the empirical distribution because we are looking at the probability that we are between 100.6 and 101.4. So this one, that the sample mean lies between these two values. So according to the empirical distribution, the percentage of data which lies between these two is 95.44 or 0.9544. Now that's just from remembering. But if you still want to use our calculators, you will still see that it will give us the same answer. Let's go ahead, get our calculators, guys, and do the math again. So second inverse, cursor, normal CDF, enter. Now remember, the lower is 100.6. The upper is 101.4. The rest is the same. And your answer is 0.9544. Okay. One last example in the central limit theorem. Okay. In a recent study reported on October 29, 2012 on the Flurry blog, that the mean age of tablet users is 34 years. Suppose the standard deviation is 15 years. Take a sample of size n100. So we would now like to find what is the mean and standard deviation for the sample mean ages of tablet users. So the moment you see sample mean, you mean you're talking of the sampling distribution of the sample mean over here, okay? Now, you're looking at this one. So now remember that this is going to have a normal distribution because n is very large. So the mean of the sample mean is the same as the population mean, which is 34 years, but the standard deviation of the sample mean is going to be sigma over square root n, which is 15 is the population standard deviation divided by square root 100. The answer is 1.5. So what does this distribution look like? Because by CLT, the sample size is very large. Remember, the sample size is n greater than or equal to 25. The sample mean distribution will always look like a normal distribution. Okay. Now let's look at some other questions here. So what we just found was that the sample mean of the tablet users has a normal distribution of 34 years and 1.5 standard deviation. That's what we got from the last slide. Okay, here's the question. What is the probability that the sample mean age is more than 30 years? Okay, so let's first make our sampling distribution, the sketch, just a rough sketch. So the amount here normally is 34 and you're going in 1.5, so it is 35.5, and then you add another 1.5, 37, another 1.5, 38.5. Okay, now let's go back. 1.5 is 33, then 32.5. And then another 1.5, 31. Another 1.5, 28.5. You are looking at what is the probability that the mean age is more than 30 years. Where is 30? 30 is very close to the second, so more than 30 years. What again we're going to do? Normal CDF, 39.99, 34 and 1.5. Let's go ahead, plug it in our calculators and you will see the answer is 0.9962. Let's do it. Get your calculators, guys. We're going to do it together. So second was normal CDF, enter. Now the lower, because the lower is 30. The upper is 999. And the mean here was, what was the mean? Was 34 and 1.5. So mean is 34 and the standard deviation is 1.5. Cursor to paste, enter, enter. Oops, I made a mistake. Let's go back. What was the mistake? Here's the mistake here. Let's do it again, guys. Okay. You see the mistake, guys? Oops. It just did not work. Okay. That's okay. So this was the mistake. You see this one? I was in a hurry. So guys, don't be in a hurry. Second and was. Oops, again, something messed up. It's a normal CDF, press enter. Now that's where the mistake. The mean was to be 34. That was, I think, hit the LN button. Okay. Cursor down, down, enter, enter. 0.9961. Okay. Let's see, is that what I have? 0.99616, which is roughly 0.9962. Yep, that's what we have. Okay, here's the next question. Find the 95th percentile for the sample mean age to 1 decimal place. Okay, now what does that mean? Let's look deeper here. It means what is the value of the mean age of the tablet user if 95% is less than that. So in other words, you're looking at, so this one is 34, okay? Now you are looking at 95%. So what is this K value such that it's the 95th percentile? So this K, 95% of the tablet users are less than K. So that's what you're trying to figure out. In other words, you're given the area under the curve, 95%. And you want to find what is this K. So what you say is, you have to use the formula in norm. So that's how we find it out. So let's go ahead, plug in our calculators. Okay. Try to get this here. Okay, so we're going to do this one. Okay, so second was, now take your cursor to number 3, press enter. Okay, let me take the cursor here. Now area is 0.95. So 95th percentile means 0.95. The mean here is, what was it? 34 years, and the standard deviation was 1.5. Remember, tail is left. Now this is the latest calculator I have, but if you have an old one, by default it is always left, guys. Keep that in mind. So these are the 3 values you need, and do not touch the left center here. Just take your cursor to paste and then enter. And you will get the answer to be 36.46, so 36.5 years. So this is the sample mean age of 36.5 years is the amount of, is the age by which 95% of the data sets falls below that. Okay, because the problem is talking about the mean age of tablet users, the sample mean age of tablet users. Well, thank you guys.